Hello and welcome to this video for transforming our Quixel rocks into more custom and more efficient versions. First, I will go through the importing the Quixel assets from the fab. So here we are, we have our meshes. I have selected 7 rocks for this example. I will just place them. And as you can see, the scale is not good for this presentation, so I will just scale them up and see on a uniform level. Alright, here we are, our 7 rocks perfectly aligned. And now we will take a look on these assets. Quixel has updated the workflow and they have the albedo, the normal and ORM texture sets. And as you can see, as you know, the metallic channel is most of the time is unused. It's an unnecessary channel for us. So the workflow I want to use is to pack the occlusion and roughness channels into a normal texture with packed normal. You know, this workflow is also contains just combining R and G channel of the normals into a packed normal. So we can use 2 more extra channels in a packed custom texture, which will be stored the occlusion and the roughness now. And in the LayerCraft, we will use the texture bake. I have a special utility for this operation. In the Unreal, you can just use the existing textures and bake your custom packed texture. So I will just select the existing textures. So this is my ORM texture. I will just place them into the occlusion and roughness channels in my blueprint and the normal to the normal. And I will just use the same name to consistent workflow. I will just copy the name, and if I paste this into here and just delete the T underscore and the last part, because the blueprint will create the naming automatically. So I will select normal, occlusion and roughness and click bake. When we do this, it will be created in the levels folder where we store the level. Now we have our newly baked texture, and here we are. It's a 4-channel texture. Here is the occlusion and here is the roughness. It's all set up, and now we can directly use this in our material. So I will just copy my existing rock and I will go through the workflow. So I will create a new material instance, call this Quixel rock, and open it. And let's assign the new created material, and we will build up our material now. So in the textures folder, let me just disable the texture array from the previous workflow. So here I have albedo and packed normal. We have 2 inputs as texture parameters. And here we are, we just have our albedo texture, and I will assign our newly created NOR texture. When we assign this, you can see we have the normal information. The roughness is a bit off. Let's quickly make it, let's compare this with the original texture or original material. So this is the original Quixel material, and we will just compare the visual quality. In the response, I have the really low roughness. So when I make it 0, as you can see, it is almost identical. We have achieved the same look with only 2 textures. So this is one optimization. I think, you know, in the material shaders, the very important optimization is the reducing the texture samples. So this is what we are going to do now. I will just speed up again and create each texture sets packed texture. So I will just copy the name, select my original packed and normal textures, and just use the same name and just just click the bake and it will be created. So I will do this operation for all the textures. And here we are. We have created all the 7 textures we need. So I want to use a texture array workflow. This is how you create the texture array. Just right click all the textures selected and let's name this TA underscore the Quixel rocks NOR. So we going to create this texture set and move them to this folder of the assets. So we have our normal textures now. Now we can work with the color information. We need to create a texture array for the albedo textures also. So I have here a bit extra texture, a bit extra assets texture. So I will just eliminate and select the correct ones. So I have copy and paste the new textures that we're gonna work on. Select all the textures, save them, and now let's create our texture array for this also. We will call this Quixel rocks color or B, and as like the Quixel used. So we have our 2 texture arrays. Let's compare them if the naming and all the indexes are correct. We will open these up. Here you can see we have the 2 arrays now. Let's check the inputs for now. Here are the naming, and if we can compare, the names are identical, as it is important for each index using the same texture set, because our materials will use the indexes to assign each texture set. So we enable the texture array, and we need to assign our newly created texture arrays. These are here, and just drag and drop the texture arrays, and here we have in the 0 we have the correct one. We have the texture array size 7. It's about how many textures you have, because it will select each ones. So the thing is, if I select everything, all the meshes, and assign this material, they will all try to adapt to the same texture index, which will be 0 by default, and they will try to use the first meshes texture set. So here is the custom data will be really useful for this. We can use this material instance in different versions. Here we have the custom primitive datas for each parameter you want. It includes tiling and colors information, and also the texture array index. So the first one will be 0, the second one will be 1, and immediately you can see when we assign like 2 for the third one, it will assign the correct texture set and apply to the material. So this way we can use single material instance for as many assets you want. You can do this same method with like 50 rocks, and you can make them share single material instance, and with the nanite workflow it will be like single draw call, which is really efficient. The nanite optimizations really going to that way, so this workflow will be really useful in the future. So let's compare them to the original ones. Here I am just assigning the original materials to each mesh, and you can see they have the identical look. One in the front part we have 7 texture material instances, and on the back side we have only 1. So this is the workflow. So let's make it a bit more spicy. Let's increase about our details. So I will just copy these, and under the rock dirt category I will just copy and paste our material, and let's rename this underscore dirt. So I want to show a new texture information, the material selection. So this is the same setup. We have all these texture assets, texture arrays working. What I want to show is working the occlusion information into our color. And here if we enable the occlusion mask under the surface color category, as you can see, the occlusion is blue channel in our packed mask. And this way we can use this mask as like a masking for the color, and we have the occlusion mask amount and the contrast. We will just use existing base color and masking with a occlusion color with the mask. So here you can see we just adding some extra details, some variation in the occlusion data. It depends on the assets maps. So some of them will be more visible, some are more. Here the more dramatic colors will be more easily to show. You can change the amount and the contrast, so we can just have a cheap variation to our solid look. This is one way to customize. And now let's add the most common scenario on the rocks, which is the moss. So I will copy and paste again. This time I will name this Quixel rock moss. Let's assign this to the new set, and when we open this up we have this same background, maybe just a bit more less subtle occlusion mask. Alright, so add a new layer and select the master layer and the master blender. These two are the basic the structure of the LayerCraft. We are just now adding a new material layer, which is in the logic is the same as adding a new material like overlay material, and the master blender is the masking happening, how the alpha mask will be created. So as the layer I just want a moss texture. In the albedo I just assign this. Here, yeah, looking pretty nice. The scale is overall okay, but we can just, if we want, we can increase the tiling a bit easily. It is under the UV logic. So you have the tiling, just 2, and here we have more detailed moss. So in this moss texture I have a packed NOR also, the packed normal method. So if I just disable the packed texture and enable the packed normal, I can just quickly assign our moss packed normal. Here again the roughness channel will need to be adjusted. By default it is green, so if I select alpha, it is working now. Also the detail the occlusion channel needs to be changed also if you going to need further. So we have this material above, and this is like overlaying all over, and I just need a masking now. So as the base mask method, I will select under the procedural masks directional. So this will be working with the normal directions of the vertex. You can also have the pixel, I will show you on the later. So we are just masking based on the vertex normal. This is basic setup for every kind of landscape or directional masking. If we select the mask debug method, we will see the top layer will be white and the bottom layer will be black, so we can view the masking, what is happening exactly. So here you can see the faces that are looking upwards are white, and we can play with the directional amount, and the contrast will make us control the masking more. Here we just have this procedural mask that is not based on the texture or like UVs. So if we just select and rotate this mesh, this masking will be adapted. So this is very nice, but this is like a hard soft blend, doesn't have a realistic look. So if we enable the detail mask, by default we have displacement. If we select occlusion, because I have occlusion mask, I don't have a displacement by the asset. This occlusion mask will give us a pattern that we can use on the blending area. Right now it is really subtle. Let's zoom in and try to see. If we lower the contrast of the base mask, we will have more area to work on, and we can increase the breakup contrast, so we can see our occlusion mask is happening on the edges. Let's see on the different assets. Here, when we lower this detail mask amount, this is the minimum of the base mask. And yeah, some assets give you more detailed look. This is really nice on some of them. It depends on the asset. And let's view this with the layer actually. So this masking method will work for any mesh. This is the same logic. It will use the mesh's vertex data, which is already baked into our asset, and also each asset's special texture, this occlusion happening. So each asset will have its own blending method, so it will be all unique to each mesh with the single logic, single parameter, single material instance will be working on all of them. How cool is this? So now we have the pattern is happening on the edges, but you know, depends on the asset. We have this big patches of moss. So if we have this option on detail mask to use detail in the blend or overlay, which means like multiplying everything, all the mask, and it will create the soft blend on the base mask, but we can see this detail, the occlusion data in everywhere. So even on the top of the vertex, we will have more some patterns. Yeah, so moss is like this, and let's go over for the next and the last operation, the snow. Alright, so I will just copy this moss texture, moss material, and name this Quixel rock snow. And assign our material, and let's open it up. We will use kind of similar operation as the mouse with directional mask. They are the similar logic, but for this I will disable the detail mask, and in the directional mask we were using vertex normal. This time we will use pixel normal. So for all the information we have from the normal channel, we can use them as the normal direction. So we will calculate each pixel's normal. It's not depending on the vertex, like the faces direction, but after this normal calculation, each pixel's normal. So this will make you have to disable the normal blending. We cannot use normal information coming from the top because we are depending on the normal blending. So I just select the snow texture. I just have assigned the snow material, and since I disable on the blend asset, I don't have a blending on the normal. So what if I have this packed normal texture input, it doesn't matter. And here you can see the really detailed, really crispy, for like a realistic snow buildup on our rocks based on the normal information coming from bottom, the original rock. And we can also still playing with the amount and the contrast. So -1 will delete, and we just slowly build up our snow. So yeah, this is kind of like 3 different layers to be added. You can have this dirt, the color variation, the moss layer, and the snow. Most common use of the assets, all inside the single system. The LayerCraft enable you to create this whole system. Oh, this rock is missing. Yeah, it's not here. Okay, let me just put this. I will just copy this, just change its material, and all the information are in the system, so it will just adapt quickly, and it has some interesting look. So these are the rocks, and I have many other operations examples for LayerCraft. Here some different rocks from a free collection, and here I have a 3-layered wall, peeling rust, a path, like texture painting, a moss, the lava. It's also can be animated. I have the snow and the paper example. Let me show you the burning paper effect. I need to just update the location of the actor mask, which will create this burning effect. All these other examples, and all the system is one single layer and the master blender, and everything is inside this system. And before I go, I want to show you some shader complexity. Here you can see the colors of the shaders. In the front you have the original Quixel, and I think this is really impressive, huh? You have almost the same, you can see the difference between the original Quixel material and my custom texture arrayed version, which is good trade-off, and all this blending are made logically and really optimized. So thank you so much, and I hope you find this inspiring. See you next time.